So this week I've been experimenting with the new lightweight PLA filament from ColourFab. A foaming agent's mixed in with a plastic. When it goes through the hot end, an endothermic reaction occurs. It foams up, expands several times, fills itself with little micro bubbles. This allows you to 3D print your own radio control foamies, which is slightly awesome, but there are some caveats. If you print it single wall, it's a wee bit floppy. So this is my first go. Single wall thickness, and unfortunately, as you can see, it's very floppy. It's far too flexible. I did a lot of adjustment just to stop little holes appearing, and I got a lot of stringing issues, as you can see. It is floppy though. People online said it was reminiscent of texture, feel, and thickness of tent canvas, and I have to agree, that is what it feels like. It's quite robust, you can't put your nail through it, but it's far, far too flexible. Now I use Cura as my slicer, many people do, it's free and it's excellent. However, as many people have noted, it has serious issues printing single walls. It's just something they need to work at. In the meantime, there's various workarounds. The ingenious Tom Stanton has come up with some ideas, so do check out his YouTube channel. But someone on the Stack Exchange said, well, don't print a single wall, print a double layer wall, but at half the thickness, and then the problems disappear. Well, that certainly works, but in the aerospace world, we know that a single wall isn't very robust. We tend to use two walls, sandwiching a thin honeycomb core, and basically that's the ethos of 3D printing. We call the honeycomb core infill. There's a steep learning curve with this material, but after a couple of days I got this. Comprising 0.4mm inner and outer walls, that's double 0.2, and a 30% infill core. Now, it's tough as old boots. A bit too tough really, tough enough to pull Mach at low altitude. So I had another go, reducing the total wall thickness to 2mm and reducing the infill to triangles that are with webs that are 4mm apart. It's really strong. It's as tough as 5mm thick balsa, which is remarkable considering it only masses 12.6 grams. Now let's talk about printing. This was an A8 a long time ago, but like grandfather's walking stick, I've replaced the handle and the bottom end and the top end, but it's still an A8. The original hot end was pant, so I replaced it with an E3D V6 all-metal hot end, and what a difference that made. However, there's the original part cooling fan, and the combination of the two caused a problem. You have to print this material at up to 250 degrees centigrade. Now, as you can see, I don't have a cabinet or enclosure, and that's rather bold at these temperatures, and in fact I didn't get away with it, so you can be damn sure I'm making one now. It isn't quite finished. The problem was that the first layer I printed with the part fan off, and that was fine. But after the second layer, naturally I turned this fan back on again, as one does, and then all hell broke loose. First of all, the material didn't like it, because what was happening is the head was way down here on the first layer, and the airflow was bouncing off, coming straight back up into the hot end, and cooling it. And it was also producing a sort of colder outer skin in the 3D print filament itself, which caused all sorts of problems, and the foaming and the adhesion, didn't like that at all. The other problem was, I was watching the display, the hot end temperature just went into free fall. It started at 250, but over a matter of about a minute it was just regularly dropping and dropping and dropping, and then it would get to about 230, at which point the Marlin software I put on would go, we get a thermal runaway, and kill the print. Going on, it seemed very odd. These are the standard external MOSFET add-ons that everybody adds to ANET A8 because the original ones are dog and they keep catching fire. Now, these terminals are good to 25 amps, so they'll probably do 30 at a push. Whereas those MOSFETs are good to 210 amps, which is nuts, frankly. And so I thought, what's going on? So I checked the voltage across the output and the input, and I couldn't figure it out. Now, just about here, there's a little blue LED. It flashes repeatedly, and what it's telling you is that the PID controller on the main board is sending a pulse width modulation signal to the MOSFET, and you can see the duty cycle of that pulse width modulation by watching this little blue LED flash. Now, it was flashing 100%, it was just full on. So basically it was taking all the power that the main board was deigned to give it, and I thought, that's very strange. I thought, yeah. So I checked the wiring and I checked everything, and there didn't seem to be a loss. A 30 watt heating element under the hood of the hot end. And that's not actually very much, it's about the same as a fairly feeble soldering iron. They do a 40 watt version, I may well get that. And the trouble is, the poor old hot end just couldn't cope with the blast I was giving it from the part fan, plus its own fan. And not only that, the energy required to foam this material has to come from somewhere. It's a endothermic reaction, as we say, it absorbs energy. And that energy was also having to come from the hot end. So with all that extra load on it, it just, basic physics decreed that 30 watts just wasn't enough. It just couldn't maintain that temperature. So the next thing I tried is I just switched the fan off for the whole print. As you can see, I've taken away a little funnel that normally sits on the bottom of the fan to direct the airflow to the hot end. As an aerodynamicist, I'd designed my own one, and in this case it was a bit of an own goal because it was working too well. So yeah, it much prefers the fan being off, and then the thermal one-way problem disappears. It's something I may run up against later in the future, but for the moment, leave the fan off. The other problem I had, I've got most of the stuff off the glass bed, but not all of it. This lightweight 3D PLA sticks to the damn plate like glue. I use a ton of glue stick all over the heated bed, but despite that, getting the final 3D print off was an absolute nightmare. It literally hot glued itself onto the bed. I had to use a razor blade to get the damn thing off. So that's one to watch out for. Anyway, let's talk about Cura settings. The layer height and the line width are both 0.2mm. We've got a double wall on both the inner and outer surfaces, so that's 0.4. Outer wall inset is set to 0mm. Now that's very important. Whatever that feature used to do in Cura, it doesn't work anymore, as far as I can tell, so you must set that to 0. And I've switched Enable Ironing feature off. As for the infill, the original infill density has been overwritten with an infill line distance of 4mm. Stefan at CNC Kitchen has produced this chart showing you how much expansion you're getting from the PLA when you foam it at different hot end temperatures. For example, the maximum foaming occurs at about 250 degrees centigrade. At this temperature, Stefan's foam was expanding 2.6 times, so we had to reduce the flow through the hot end by the reciprocal of that, which is about 0.38, to compensate. I want to expand the PLA fully, so I'm printing at 250, but I've upped the flow just a smidge to 45 because I was getting tiny little holes in the walls of the print. Build plate temperature 65 degrees, simply because it's cold here in Scotland at the moment. Print speed 40 millimeters per second. It doesn't like being printed quickly, thin walls generally don't. I've set the initial layer speed even lower, as you normally would do for PLA, because normally it won't adhere to the bed. However, this stuff sticks like glue, so I may well raise that up again. In the travel subsection, let's talk about retraction. It's enabled. Now I've got a Bowden cable. This material is very sensitive to retraction because even when you're not printing, it still continues foaming up inside the hot end, and it will travel right up the bowden if you let it. So I've increased the retraction speed to 50, and I've increased the retraction distance from 1mm to 2mm. What I'm trying to avoid here are blobby bits on the walls of the print, and also stringing. This stuff really likes to string. Similarly, I've increased the priming, the extra prime, from 0 to 0.2. Now you should really increase that and step to 0.2, because if you get carried away you can make the most fantastically gooey mess. Cooling, I switched the enable print cooling fan off. It really didn't like it, discussed that earlier. And as for the build plate adhesion, it doesn't actually need any. It sticks like glue. I should probably just switch all of that off. So do have fun playing around with this stuff. A roll of filament may be twice the price, but as it's expanding 3 times, then you're actually saving money per print, and it is astonishingly light. Thank you for watching, and I hope to start flying this stuff soon.